Morning, everybody. Let's go to finish up today 11.3. We'll start to review for the test after that. And then just a reminder, we're going to have a quiz tomorrow over anything we've covered this week. Mostly just homework questions. So I would just go over all homework questions that I've assigned for this week. Look at your notes, but it'll be very similar to what you've done in homework for this week. The quiz will be on Google Docs. So I'll give you a link. It'll be multiple choice. And you'll just submit it. It will tell you right away what you got right and wrong. So that will be a link on GradeLink that I'll email you all, and you can look at GradeLink for it as well. And that'll be anytime tomorrow you want to take the quiz. Any questions about that before we get started? Okay, so let's finish up 11.3. So we have a sample of FeCl3. They might ask you how many Fe3 plus ions will there be in a certain amount of grams. So the question is, in 18.1 grams of FeCl3, how many Fe3 plus ions will there be? So what we need to do is go from grams to moles to start with. So reverse conversion is from grams to moles. And then go from moles to particles, or in this case, ions. So it's going to be a two-step process. So we'll start by going from grams to moles. We'll do 18.1 grams of FeCl3 and convert that to moles. So in order to find out the molar mass of FeCl3, we go to the periodic table, we'd see that Fe's molar mass is 55.85 grams per mole. And then Cl's molar mass is 35.45. And there's three Cl3s, or there's three Cl's. So you have to multiply that by 3. And then add 35.45 times 3 plus 55.85 to get FeCl3's molar mass. And what we'd find is that FeCl3's molar mass would equal 162.2 grams per mole after we add 55.85 to 35.45 times 3. So that's what we're going to put down here. So our conversion is 162.2 grams for every 1 mole of FeCl3. So what we do is we take 18.1 divided by 162.2, and we get 0.112 moles of FeCl3. So we've gone from grams to moles, now to go from moles to ions. We have 0.112 moles of FeCl3. We can see in this compound that for every 1 mole of FeCl3, we also have 1 mole of FeCl3, of Fe3 plus. So we would also have 0.112 moles of Fe3 plus, because this will break apart into water and you get Fe3 plus, and you get 3 Cl minuses. So if they're asking for moles of Cl minus, you multiply it times 3. But for moles of Fe3 plus, for every 1 mole of FeCl3, you also have 1 mole of Fe3 plus. So it's the same amount of moles, whether it's Fe3 plus or FeCl3. So now that we know that, we can convert from moles of Fe3 plus to ions. So to convert from moles to ions, we use Avogadro's number. For every 1 mole, there are 6.02 particles. So we just multiply 0.112 times Avogadro's number, and that will give us how many Fe3 plus ions there are. So we get 6.74 times 10 to the 22nd ions. Now let's say they also asked for moles of Cl plus. Let's go and see what that would look like. So we found moles of Fe3 plus. Let's find moles of Cl minus. So what we see here is that for every 1 mole of FeCl3, we have 3 moles of Cl minus. So we had 0.112 moles of FeCl3. If we want to convert from moles of FeCl3 to moles of Cl minus, we would use the ratio for every 1 mole of FeCl3, we have 3 moles of Cl minus. So we do 0.112 times 3. That gives us 0.336 moles of Cl minus. If we want to know the ions, we now multiply by Avogadro's number. So we take 0.0336 moles of Cl minus and multiply it by 6.02 times 10 to the 23rd. And that will give us 2.02 times 10 to the 23rd ions of Cl minus. So that's the only new step here, is multiplying moles by Avogadro's number. Besides that, it's the same as we've done yesterday and the day before. You get the molar mass, you take the amount of grams, divide it to get the number of moles. And today it's just one step further, multiplying moles by Avogadro's number to get how many particles you have. One last thing today. They're asking, we'll do the same one, FeCl3, stick with that one. The question that they're asking now is, what would be the mass in grams of 1 formula unit of FeCl3? So they're asking for the mass in grams of 1 formula unit So a formula unit, remember, is just one of these things. That's one formula unit right there. It's just 1 Fe and Cl3. Well, remember that we found the molar mass of FeCl3. The molar mass says that in 1 mole, you have 162.2 grams. So that's our conversion. And we would need to use that to convert to grams of one formula unit. So we have 162 grams of FeCl3 for every 1 mole. And we know that for every 1 mole, you have Avogadro's number. So we would use this conversion factor right here. We would take the molar mass and divide it by Avogadro's number. And that would give us the mass of one formula unit. Because if we have this many grams, 162.2 grams of FeCl3, we have this many formula units in it. So we need to divide that by the amount of numbers we have in it to get the mass of one formula unit. And that will give us 2.69 times 10 to the negative 22nd grams. And that would be the mass of one formula unit of FeCl3. So in a question like this, you just take the molar mass of the compound divided by Avogadro's number, and that gives you the mass of one formula unit. Any questions about that? All right, so today for homework, it's just a few problems I want you to do. 43, 45, and 50. That begins on page 338. So I'll write in here too for you, but I want you to do 43, 45, and 50 on page 338. And then study for the quiz tomorrow. Study the homework problems we've done this week. And your notes. The quiz will be very similar to what we've done in homework this week. There'll be multiple choice questions on Google Docs. I'll give you a link tomorrow on GradeLink. All right, for number 50, let me just go through it with y'all because you can't see the answer in the back of the book for this one. So just to make sure you got it right. It's asking how many moles of K, C, and O atoms are there in 1 mole of K2, C2, O4. And what this says is that for every 1 mole of this compound, you have 2 moles of K, 2 moles of C, and 4 moles of O. Yes, that's what your answer would be: 2 moles of K, 2 moles of C, and then 4 moles of O. That's all there is to that one.